Triangle over a rectangle. All right. And our job is to understand that the distance around the outside of the window is 20 feet. What? Okay, yes. The distance around the outside of the window, so this whole thing's the window, yeah? So the distance around the outside of the window, yeah, the perimeter. Distance outside window equals 20 feet. All right, perimeter. So therefore, we could just say that the perimeter equals 20 feet. That automatically tells you what your secondary equation is going to be. That's your perimeter secondary equation. All right, so we want to find out what dimensions will result in the rectangle having the largest possible area. We want to find, let's label our dimensions. What do we want to label this? We can make that X. And then what do you want to label this? K. K for Ketna. And really, it doesn't say whether or not it's isosceles. It should, yes. So let's assume that this is an isosceles rectangle. No, triangle, sorry. This is isosceles triangle. So the most appropriate variable right here would be what? Height, H. Okay. So the
base of the triangle also.
Yes, but I don't have to label that. I just it's kind of like just common knowledge.
Is that But is that in the? Is it like is the question saying that it's like not there? Like there's not a. Because if it's there, like if there's like a board right there, then there's extra.
Well, here's the key word. It's outside. The distance outside the window is 20 feet.
So that doesn't even. It's not even included.
Yes. Yes. Okay. So we want to find X, K, and H such that we maximize the area. Whoops. All right. Man, I had an 8-pointer right between the eyes this weekend. I was just scanning my scope across the bush, and he just stared at me, and my crosshair was right between his eyeballs, and he was just like, "Do it, I dare you." And I was like, "I'm gonna wait." He put his head down, didn't bring it back up. That would have been my first deer. All right. So, all right. Keywords: maximize the area. So our primary equation's area. So this is a compound area. What is the area of this rectangle? K times X plus the area of a triangle, which is 1/2, which in this case would be 1/2. What's my base?
Oh, 1/2 X.
X times?
No, wait, 1/2 H times H?
Times H. 1/2 base times height, because a regular triangle's equation for area is 1/2 base times height. So it's going to end up being 1/2 X times H. That's the regular equation right there. All right, so let's just take a look at our primary equation. I'll just put KX. All right. So once again, our problem is that we have too many variables. 1, 2, 3 variables. Actually, 4, yes.
No, that's, yeah.
Okay. All right. All right, so here we go. All right, let's take our, we know our secondary equation is going to involve perimeter, okay? So let's go ahead and do our secondary equation. Perimeter is equal to, all right, what is our perimeter going to involve here? 2k plus x. Okay. All right, so let's look at the triangle right here. This would be, how would we find these sides right here? Yep, Pythagorean theorem. We'd have to use Pythagorean theorem to find those two sides.
So it would be the square root of x times h?
Well, this right here is 1/2.
Oh no, it's 1/2 x?
Yeah. So let's take a look at that triangle, okay, guys? All right. So this is 1/2 x, and this is 1/2 x, and that's your height. Okay. So what did the Pythagorean theorem tell me to do right here? This is a squared plus b squared equals c squared. All right, which would it be?
But if you just square 1/2 x, what did you get in zero?
Nope. It would be, sorry, it would be 1/2 x times 1/2 x, which is 1/4 x squared plus h squared equals this c squared. Okay. All right, so we want to solve for c, okay, and we have two of them. All right, so basically we're going to square root both sides, and c is equal to the square root of
1/4 x squared plus h squared.
Okay, so there's our c. Okay, but how many c's do we have? We have two c's. So what are we going to put in our perimeter formula? We're going to put two of those c's. So 2 square root of 1/4 x squared plus h squared. All right. So let's take a look at our secondary equation. All right. What is the parameter we're given here? It's 20. So the perimeter is 20. So here we go. 20 equals 2k plus x plus 2 square root of 1/4 x squared plus h squared. Okay. All right. Now notice our secondary equation right here. All right. How many variables do we have?
3.
Okay. So here we come across a problem. We can't fix it. If we solve for h, what are we going to be left with? K and x. Okay. Let's take a look at our primary equation. All right. So if we plug in h and we're left with k and x, how many variables will we still have? 3. Area, k, and x. Let's say we solve for x, we're going to still be left with.
What if you solve for x and then plug it back in for x?
Solve for x and then plug it back in for x?
In that equation.
In this equation?
Yeah.
You'll end up with a true statement. Anytime you do the substitution method, I'm serious, I'm not lying. Anytime you do the substitution method and you plug it back in for itself in the same equation, you end up with a true statement. systems of equations. My ninth graders are doing it right now.
What does that mean?
Yeah, I know.
What does that mean?
Yeah, two statements.
Here, I'll show you. Alright, so
Okay.
if I solve for x right here, I end up with 20 minus 2k minus 2 square root of 1/4 x squared plus h squared equals x. That's what I end up with. Okay? So I solved for
Oh,
x.
but if you all plug that back in, it's just going to be cheating.
If I plug it back in for x, I end up with 20 equals 2k plus parentheses 20 minus 2k minus 2 square root of 1/4 x squared plus h squared.
But then don't you plug in x?
Plus,
But don't you
hold on, plus 2 square root of 1/4 x squared plus h squared.
Wait, wouldn't you plug in
Yeah, for
the
x
x squared too?
you plug in? You said that.
Oh, yeah. Now it's going to get dicey. All right. Plus 2 1/4 2k, oh sorry, 20 minus 2k minus 2 square root of 1/4 x squared plus h squared plus h squared.
Sorry, guys.
But
All right. All right, and what's going to happen is all this stuff is going to cancel. Yes, all this stuff will cancel, and you'll end up with 20 equals 20. I'm serious. You just got to take my word for it.
All of that to say is
All right. So homework for tonight will be watch a video over number 8.
Okay.
so what are we doing? So just
Seven.
stop there.
Can we just
Yeah.
stop at 7?
You can't do it. There's some situations where you're not going to be able to
Yeah.
Look it up.
all of that.
finish the optimization.
D-U-N. Go ahead.
Now, okay, there is a way to do it, but I'll probably either post a video or we'll go over it tomorrow. That triangle has to be some sort of special right triangle where h can be written in terms of x, and then it's good to go.
Alrighty.
But if you're done with 1 through 5, awesome. You got no homework tonight. I'm gonna post a video about number, where did I say? 8. And then we'll actually just do nothing but practice in class tomorrow. I can post one for 7 too, yeah.
I mean, if I'm the only one
Yeah.
Well, it's either that or go over it in class. And honestly, I'd rather post a video than go over it in class. And I'd rather see you doing it in class instead of just me doing it in class. All right, guys, go.